All right, so let's say they give you this situation where you have this hockey puck of mass 6 kilograms on ice, and you apply a force of 5 newtons, and they ask you, what is the acceleration of the hockey puck due to the force? Could you answer it? If not, continue watching this video. So to start, we need to know Newton's second law, which states that if a net external force acts on the object accelerates. The direction of this acceleration is in the same direction as the net external force, and this force is given by summation of F equal to mass times acceleration, where the summation of F just means the sum of all forces, so it's just a fancy way of saying the net external force, and then m is equal to the mass of the object, and a is the acceleration in the same direction as the summation of F, as Newton's law stated. So with this, we can bring it back to our example here. So if we apply Newton's second law equation here, we can note that 5 newtons is going to be the net external force on the hockey puck. The direction of this force is going to be to the right, so we know that the acceleration is also going to be in this direction, as Newton's law states. And then the mass is 6 kilograms, and we're solving for the acceleration. So when we plug all these values in, we get this expression here. So we can isolate for the acceleration by multiplying both sides by 1/6 kilograms, and then we can divide the amplitudes, divide the units. But what is newtons divided by kilograms? So if we remember that newtons is equal to kilograms times meters per second squared, we can plug that in, and then the kilograms cancel, and it leaves us with meters per second squared, which makes sense because these are the correct units for acceleration. Plug both these values for the units and the amplitude in, we get this final answer, and this is the acceleration due to the net external force on the object. So if we go back to our image here, the net external force on the object is just 5 newtons because that's the only force acting on it. And we can note that the acceleration is in the same direction as the net external force, which aligns with Newton's second law.